Just 2 minutes, sir. We'll start. Some participants have not got the link, so I just share it with them. But just 1 second, sir. Just 1 second.
I think now I can unmute myself.
Yeah. Yes. So we have around 24.
So you have muted everyone, or they can unmute yourself and ask question if there is need.
Sir, they can unmute. This is basically a meeting, so they can unmute as and when they
Okay.
want it. They
Because
need not.
initially when I was trying, it said like I can't unmute, so that's why.
No,
I'm just
sir.
checking.
No.
Hi Sandeep.
Sir,
I was just checking whether Sandeep can unmute himself. So he can't unmute.
no. Means I think so. Just 1 second.
I think he
Yeah, now all can do it, sir.
okay.
Yes. Thanks.
Okay. So you are like in the academy or industry or Sandeep?
No, I'm a professor here, assistant
Oh,
professor.
you're a professor at okay. Anyway, nice to meet you.
Jaipur. Yes. Thank
What's your area of research?
you. Actually, I was doing computational two-dimensional material like graphene and I was to this type of. But in my research scientist in Sweden, I was involved in organic electronics and this energy storage also using organic material molecules like most. So we developed this most. It is we are putting in the sunlight and the isomer it transform into isomer this organic molecule.
Okay. So that's more like the material side, right? And yeah.
Yes.
Okay.
Chemistry, organic material.
Chemistry.
Organic.
Yeah. Anyway, my expertise is more like the electrical side of battery, not the chemistry or material side. Yeah.
Yes, but I'm a computational scientist. So I was focusing on computational part.
Okay. Altab.
Yes, sir.
I think
we can start, sir.
we'll not have enough time to introduce everyone independently.
So maybe on one of the days in between, we can, whenever we get time, we can ask them to introduce them.
Because I just want to get some, idea like about that attendees, like their level, like if I present like in front of academics,
Yeah. Sir,
and then like someone who is doing PhD or someone already have got PhD or somebody in industry and someone who is doing PhD or someone like undergraduate. So
sir,
the presentation style should be and materials also should be defined. But if we have all of them,
yeah,
then probably I should have some trade-off having like all
we
levels, some basic, and then something in middle, and then something which should be for research level as well.
sir, we have MTech students, and we have got no undergraduate students have been allowed. So
Okay.
we have postgraduate students, we have got PhD scholars, we have got faculties. We also have people who have finished their doctorate, and we have got an industry personnel as well.
Okay, so that's mean it should be mostly like the research level, but at the same time I'll also give some introductory
Yeah.
background as well.
Yes, that would be good, sir.
Um,
Yeah, so I think so. I have already introduced yourself.
yeah, I don't have to introduce again.
Yeah. Jahangir, in this, actually, what happens is in WebEx, your PowerPoint is also visible and your slides are also visible. So whatever
Yeah,
you open,
here always we use Zoom.
yeah.
But I think I should be fine with WebEx as well.
Okay, no issues.
So should I start?
Yeah.
So again, good afternoon, everyone. So today I'll just give some introduction about the course, but the main materials I'll start from tomorrow. So today my presentation will include initially few slides about the course learning outcomes, then some background about energy conversion, then I'll take you through some issues, trend and solution of power conversion. Here I said yesterday, that means what happened in the past, and then what is happening now, and what we expect that will be happening in coming years. And as I mentioned previously that, if you have any question or any comments, so feel free to stop me any times. You don't have to wait like to ask question at the end of the presentation, because this one I would like to make it more engaging, as I mentioned, but without your active participation, that wouldn't be possible. So as I say, if you have got any question, comments, feel free to stop me any times. So as I mentioned, this is the outline for my today's presentation. So as I said, initially I'll give you some quick outline of the course, and then I'll briefly talk about introduction of different forms of energy, because this subject is mainly on energy conversion. And as you know that, energy conversion happens in most of the devices internally, and like one of the objective, we always try to improve the energy conversion efficiency, which is also related with the equipment size and other performance as well. So this is one of the issue that we'll be highlighting here when we'll be talking about any technology. For example, it could be solar photovoltaic system, it could be wind turbine, electric vehicles, battery, hydrogen fuel cell, or some of the application that I might also cover next week. It could be a microgrid or a smart grid application as well. And next, I'll be highlighting here that power conversion. As I said, that's here I'm saying like yesterday to tomorrow. So that means yesterday means like in the past, tomorrow in the future, and what is happening currently. And I'll also, highlight some issues and problems. And then I'll stop by showing some conclusion that is, drawing from this presentation. So you might heard about energy engineering, which is, comparatively a recent engineering discipline, which mainly deals with, energy efficiency, energy servicing, energy management, different alternative form of energy, etc. And energy conversion, transportation, and storage technology. That's, as we mentioned, in our previous discussion as well, that would be are some of the key technology in future energy system. And I hope, from this subject, that will give you some fundamental knowledge as well as some advanced understanding in the area of energy conversion, storage technology, and some of their current and future applications. And some of the topics here I mentioned that we'll be highlighting here. But if we get time, as I mentioned, like I know we'll be also highlighting some not only devices but some real application as well. So here the topics that I thought I'll be highlighting, that's different forms of energy, and then the energy conversion that happens in photovoltaic system, wind turbines, fuel cell, batteries, as well as electric vehicles. Both are battery, but one is stationary and another is mobile, and some of their applications. And when we'll be talking any of this technology, we'll always highlight what are the different energy conversion that happens internally, what sort of efficiency we are getting, what are the different losses that's actually happening, what are the limitations, what could be the possible way to improve the energy efficiency. And as I mentioned, that will also include energy storage technology. And probably, I will also highlight supercapacitor with battery technology as well. So these are the, 5 learning outcomes that I think all of you will achieve at the end of this subject. So the first learning outcomes, I think that you will be achieving that when you complete this subject, you'll be able to describe physical basis and also associate performance characteristic index of different energy conversion technology as well as storage. You'll be able to outline what are the economics as well as technical issues concerning energy technology and systems. We'll also be running some tutorial session to solve some problems related to these topics, which will help you, to identify, formulate, and also provide solution to complex problem independently, which will help you to find the performance of energy conversion from one form to another form. We'll also be able to analyze the different performance parameter of energy conversion as well as storage systems. And finally, you'll also be able to evaluate and identify what sort of technology as well as storage is suitable for certain application, when we'll be mainly talking about the application of these different technology that we'll be highlighting in this subject. So I'll be sharing the slide, and at the same time I'll also send some recommended readings to Dr. Altaf, and Dr. Altaf will share those readings with you. But on top of that, even if you would like to study further, these are some of the books which is like mostly probably available online. So if you would like to read further, you can also have a look on those additional resources. Now, as this course is energy conversion, you know that energy actually everywhere. Whatever we do, whatever we use, everything actually uses energy. So for example, that you can actually hear energy, and that is like a sound. You know that sound is energy. We can also see energy, that is light. Light is also one form of energy. You can feel energy as well, that is like a wind. And as I say, like, we use energy when we do any work. For example, when you hit a football, you actually use energy. When you lift your book, you also use energy. When you compress a spring, you actually use energy. So energy is like everywhere. And the energy sector, whatever devices we use, they also have energy. And this is not like a single form of energy. Actually, internally, always energy is converted from one form to another form. And as a engineer or as a researchers, we always try to improve the energy conversion efficiency, because if we can improve the energy conversion efficiency, so that means we can make the product more concise, lighter, and at the same time it would be also be more cost effective, because it will use less raw materials to provide certain amount of power. So it would be more like energy density would be higher as well. So as I mentioned, energy exists in different forms, and some of the example are, I already mentioned, that's light energy, heat energy, mechanical energy, gravitational energy, electrical energy, sound energy, chemical energy, nuclear energy, and so on. So for example, when you're talking about solar photovoltaic system, we are taking light as an input energy, and then we are having electricity as an output energy. Same for wind turbine. So wind as a input, then we convert it to mechanical, and then finally we convert from mechanical to electrical energy. So in basically, there are two major form of energy. One is kinetic energy and another is potential energy. That's all of you know. And these are also, involved with the technology that we'll be talking about. For example, if you think about like a potential energy, like many of this, power system devices, when they are like stationary, they have got like potential energy. And when they are rotating, for example, wind turbine, they have got kinetic energy. So what I'm trying to say that all the devices, most of the devices that are involved in the energy sector, they are using energy in one or other form. And here, this subject will highlight the energy conversion from one form to another form. And in energy conversion, we'll discuss what are the potential challenges and opportunity that also could be utilized to, to further improve the energy efficiency. And again, that's I already, mentioned that's like in the potential and kinetic energy. So as you know that when something is stationary, so here at this point, potential energy will be maximum, and here it will get maximum kinetic energy when it before touching the ground. And already, you know that the properties of energy. So I believe everybody knows that energy comes in different form, which I mentioned that already, that can be divided into potential or kinetic energy. Energy can be converted from one form to another form, vice versa. And you know the energy cannot be created or destroyed. And that is the law of thermodynamics. So we don't get 100% efficiency because some of the energy we say is actually lost. So that means that lost energy actually is again another form of energy. So that's the heat energy. So at the end actually it does not actually destroy it. It is another form of energy, but we don't utilize it. So if we could utilize those lost energy, our efficiency even could be higher. So as I mentioned already, also there are many forms of energy, but these are the 5 main form of energy, that is heat, chemical, electromagnetic, nuclear, and mechanical. And as an engineer, I believe all of are familiar with this form of energy. So I'm not going to talk about in details about this because you already know about that. And also we'll be talking about those technology. We'll also be using those form of energy again. So let's initially start with the past. What happens with that energy conversion? And again, when we're talking about like different form of energy technology, you might know that the power electronics, which is very important part of those technology, because without power electronics, even we can't think about the performance that we are getting either from solar photovoltaic system, wind turbine, battery, electric vehicle, or any other technology. So the power electronics is actually a heart of all those technology. So again, I would like to check again. Can you hear me clearly? Or you have got any problem?
Yes, sir.
Yes, sir, we can hear you clearly.
Yes, sir, we can hear.
Okay, thank you. So you might know that if you think about the power electronics, the inverter and converter we are using now. So the initial, like the power conversion, that was like static power conversion. That is happened long time ago, and it was not actually real power electronics that we are using now. So the first power converter, that was like a oscillator, and you might know that Henry's Hertz, he was like developed this initial oscillator, which was something like an electromechanical switch in 1987. And then Nikola Tesla, he developed a high frequency transformer for wireless power transmission in 1980. And you might see this, receiver transmitter that was actually used long back. But when actually use those technology, so the real problem was like high volume of passive device like inductor capacitor, and which contributed a very large losses, and that's how its efficiency was quite low. Same thing about the solar photovoltaic system. So that was also first installed in 1884 in New York City in a rooftop, and here you can see that fast photovoltaic system. And after that, it has been almost like a century and a half, where we have got like continuous improvement in solar technology. Although I mean, not that much happened in the past century because of like many political and other reason. Because most of the power was coming from fossil fuel. But as you know that in recent year, due to climate change and the commitment from most of the country to achieve net zero by 2050, like the different forms of renewable, they have got like significant demand all around the world. So again, I mean, what I'm trying to say that when initially, I mean, we install that photovoltaic system, so the initial efficiency was just like 1 to 2%. So that means like 98 to 99% energy was lost. Although still, I mean, the solar technology that we currently use, energy efficiency is not that high, but it's much better than, I mean, initially when we started that solar power generation. So same for like wind turbine. So the first wind turbine that was used to charge a battery in 1887 by Scottish academics. James, he actually used that in a holiday home just to light his home by charging the battery. And that was the wind turbine, which was like almost 4 tons of 4 tons its weight. It was 60 feet long, but only it was generating 12 kilowatt energy from that particular wind turbine. But as you know that currently we get like 7, 8, 9 megawatt from a single wind turbine, but that was very compact if you compare with this one. Same for like the battery as well. So the first true battery was invented by that Italian physicist. You might heard his name like Alessandro Volta in 18. But the principle was same, that it has got anode cathode, and there was like he was using closed sack in salty water just to separate this anode and cathode. And it was produces like one cell was producing 0.76 volt. So the power electronics, again, as I mentioned, this is a important technology which contributed significantly to improve the energy technology. Was actually really born in 1940 and 1950 with the invention of solid state transistor, which actually helped to get rid of the mechanical switch and come to like using power electronics switch. And then silicon control rectifier is here, that was invented in 1956. Again, after that, we have got silicon control rectifier, BJT and MOSFET that actually played a significant role in power electronics application. But it was not possible to design high power, high voltage and high frequency power converter, because as you know that BJT and SCR, they are, not that very high frequency, and speed is comparatively low. MOSFET was fast, but again, that is have very high on-state resistance at high voltage. But after that, when you got IGBT, that solved many of the problems that we have got BJT and MOSFET. And then we can say that power electronic was born at the second time after having all those new technology. But in recently, you might heard that still, I mean, we are using MOSFET and super junction silicon MOSFET. But in recent year, you might heard about that silicon carbide and gallium nitride. They are like a game-changing technology because they have got very high current, high voltage capacity, and also switching frequency also very high. And that's why, as I mentioned, that due to this power electronics, I mean, they are utilizing in most of the technology that we are currently using, either in home appliances, audio, video, communication, industrial application, transportation, even for the controlling purpose as well, like a different sort of fax devices. So what I'm trying to say that in every sector, I mean, power electronics has got enormous application. So all the things, I mean, you can see here for like the residential, commercial, industrial, and for transportation, like either car or even like buses, train, Airbus, in everywhere. I mean, currently power electronics, inverter, converter, they are playing a significant role. Not only that, as I mentioned, in storage, wind turbines, pumps, battery, even like semiconductor, SMEs. That is also, I mean super magnetic energy storage system, SMEs. There also you find the application of power electronics. Now, what is happening with the current like renewable and electric vehicles? So here you can see it, like in recent year, the electric vehicle sale has gone up significantly. Like, sorry, any problem?
No, somebody had a mute on. Wait.
Thanks, Altaf. So what I was saying that, I mean, in 2021, almost 99% of all the vehicles that is running worldwide are currently electric vehicles. But I believe that by 2030, so many prediction has been done in different countries, and it is expected that almost 50% of the world vehicle would be electrical by 2030. But I mean, in the next 10 years. And even some country like UK, they mentioned that after 2035, they will not be selling any normal, IC engine based vehicle. So in that case, I mean, everybody would be forced to buy, I mean, electric vehicle. Same in Australia also. I mean, they expected that by 2030, at least 30% of their vehicle will be electric vehicles. So as you know that the electric vehicles have got a huge battery capacity, and that gives us additional benefit to utilize those battery not only for your transportation but also for your storage and connecting with the electrical power sector and solve many of the problems that has been introduced by the integration of large scale renewable in the grid. Same for here, like renewable energy as well. So you know that renewable energy sector is getting momentum in all countries, including Australia as well as India. So in all countries, there are different forms of renewable is getting popular, but definitely dominating one is the wind and solar. But at the same time, we are also having bioenergy, geothermal, marine, and hydropower. That is not new. That is, I mean, are available in different country, and which is also a source of renewable as well. Same for storage technology as well. So here you can see that global energy storage market, so which is like currently in 2021 almost like 1500 gigawatt hour, but by 2050 it is expected that it would be like 2500 gigawatt hour. That includes both stationary, that's just the normal battery, as well as transportation sector. So that's the current and past picture of energy conversion that is already happened or currently happening in different countries. So what is actually coming in coming years? So next, would like to highlight what we are going to see in coming next to 5-10 years. What is the future of power conversion devices? What are the research challenges? Is there like only single technology will be getting popular, or there would be like a mix of technology for any devices, for example wind, solar, battery, or electric vehicles? Then we'll also be talking about what sort of like industry that's are already in the market or coming in the market in the area of energy conversion. What are the different components which people will be researching for to improve that performance of those energy conversion devices? And what actually what are the maximum efficiency actually would like to gain? Is it like if you're getting 98%, is it enough, or even would like to go further? So if you think about like future, if you ask me like what are the first major objective, I think you'll be agree with me that the first always we talk about the cost and cost, because these are the main parameters which will help to actually commercialize as well as being sold in the market if your cost is reasonable. Because that that energy conversion technology that's are in the market for like many years, but unless it is cost effective and comparable with other technologies that's already being used in different sector, people will not use that one. So that's why the cost is the main factors, and we need to keep researching to show how the cost can be minimized. And then other important parameter is the size, because we always love to have the smaller size, lower weight, and also having lower carbon footprint. So those are the important parameters we need to keep in mind when we'll be researching that how we can improve the technology. Then losses, which is definitely again related to the energy efficiency and energy savings. Other things, we also think about the cooling effort, because when we have got the losses, and losses happens in terms of heat, and to minimize the heat we always need that heat sinks, which also increases the size. So that's why we need to think about the cooling effort as well, because that's related with the size, weight, and cost of the energy conversion technology as well. And always other important parameter is the reliability, because we want like continuous supply from any of these technologies that we would like to use without any interruption. And you might heard about that. We are also talking about that fault tolerance control, because when we're having like the massive number of even like wind, solar, battery, or other technology in the market, we want them to be fault tolerant. So even something happen in the system, we want them to not fully disconnected. So it should have something inside which actually can tolerate, or even when there's a disturbance, it should be able to supply even not 100%, but certain amount to the system so that the system can run even like with reduced capacity, not fully, shut down the whole system. So that is also, another control and definitely optimization that is also be popular in coming years. So as I mentioned, that's PV technology is already popular, but in coming years it would be even like popular in other countries, because in Australia currently we have got already like in 1 in 4 homes we have got photovoltaic system, and that is actually increasing day by day. So we are having a number of both like commercial as well as rooftop project that's happening in different state. So here you can see like from 20 to 20 there is like a almost like a linear increase in the growth of photovoltaic system, and I believe that will be continuing in coming years as well. And the price that have gone up significantly in recent years. So if you can think about that, price, like in 2007, you can see like it was like more than 7 USD per watt, but even now it's less than $1 now when you're gonna install that solar photovoltaic system. So it has gone down massively in recent year, and that trend is still continuing. So that's why, like even in many countries, if you compare the energy price like from photovoltaic system with other, already the energy coming from photovoltaic system is cheaper. And even if it is not true for all the countries, but I believe in coming next 5 years, that would be comparable to energy price that is coming from other sources. For the photovoltaic system, you might know that currently we are mostly use silicon, but the other materials which also might be getting popular in coming years, that is thin film and concentrator. So if you would like to reduce the cost, as I mentioned, like we have to reduce the material that we use. Another way, we also need to make that size compact so that it uses like lower space when we install. That also reduce the prices. So if you think about that photovoltaic technology, the upfront cost is the cost that is relevant to the semiconductor materials, area related costs, as I mentioned, like the glass installation, real estate wiring, and also the cost coming from the power electronics inverter. And if we can reduce that semiconductor material, we can reduce the cost. And as I say, like we can reduce that area by increasing the efficiency. And here, when you're talking about the efficiency, that efficiency is that power conversion efficiency. That will be talking in details in coming lecture. So as I say, like we already having like this mono and multi-crystalline that's widely available in the market, but we believe that in the coming years, mix of technology, that would be the way that future market will operate. And other thin film, for example, that cadmium, telluride, copper, indium, gallium, selenide, that I believe would be popular in coming years as well. And as I say, like the concentrator, that will be also like popular in coming years. So this is like different sort of, as I say, like these two are again mono and multi silicon. That's still, I mean, massive amount. I mean, they are coming from these materials, but as I say, in coming years, those material will come into the market as well. So we are expecting that cadmium tellurant is primarily new entry, that's I say as CIS, that might be like in a coming 5 to 7 years behind, and concentrator that might be in like in 10 years, but that will be coming in the market as well. So that's, I already mentioned, that's the PV technology mix. That will be the future of PV. So as I select different mix of technology that will be coming in the market. So different sort of band that is also coming, multiple excitation and different sort of carrier. And again, this is more like the material side, just to improve that efficiency. So if you think about like question that you will be asking, like what sort of efficiency has been achieved. But as you know that when talking about the most of the efficiency in research, that's more like the theoretical efficiency, but we need more like that real technology and commercial efficiency. That's not only the theoretical efficiency. And even the high efficiency are reported. Are this like for a small application, or I mean for a small cell, large scale, or module, that we need to be clear. And if not high efficiency has not been achieved, I mean how much it will cost to install, those sort of things, I mean we need to think about. And which technology for which application, that also depends on many things that you need to consider, and one of them definitely is efficiency. Mainly important when you have got area constant that you will be installing that PV technology. Form factor, that is also think about, it is either building integrated or conventional racks. You also need to think about the weather condition and other things, for example, dual use of land, packing density. These sort of things also you need to think about when you think about which technology you will be installing for what application. And efficiency, as I mentioned, this is definitely an important factor. And again, I mean, the technology that currently probably you are getting, efficiency might be like 10 to 20%. But as I say, like that, research efficiency is much higher. For example, that NRL, they, I mean, recently claimed that they are getting efficiency more than 40%. But again, this is still like that theoretical efficiency. I think if we can implement those sort of efficiency in real application, then I mean it would be like a massive impact on the PV technology, and even it would be more popular when you talk about that like renewable energy coming from photovoltaic system. So again, I mean, you might heard about some of this technology that will revolutionize in coming years. One of them is floating solar farms. So even if you have got like a space constant, probably this technology would be coming popular in coming years. And this is not only like space constant, but it also help to be cool. I mean, maintain the temperature of the solar technology. As you know that actually the temperature that significantly reduces the power coming from the solar technology. When we'll be talking about details about the solar technology, we'll see like how significantly the temperature has got impact on the solar output power. So if you have got this floating technology, it also helps to keep the temperature almost constant. That's how it also helps to get better output power from the floating solar technology. And if you use like on top of a your swimming pool, it will also help to keep that temperature of the water as well. So that's how probably it will reduce your heating cost as well. Then you might heard about like building integrated PV technology. That means in coming years you might use your rooftop, even your glass, your curtains, which will be made of like this PV, which not only use in your building materials, but at the same time it will be utilizing to produce power as well. Then you might heard about like solar skin, like you can see here, and also solar fabric. That means actually we can get solar sunlight anywhere. Then why not we produce power anywhere, even from the t-shirt or any other fabric we use. So if you use like that fabric with this the technology coming in the market, even we can produce power and keep produce heat from that as well. Other technology which also might be popular, that photovoltaic solar noise barrier, because in many countries, even in Australia, we have got made like a huge wall just to reduce that noise that's coming from highway and sometimes from the train or other vehicles. So why not we use like utilize those well, and using this technology which will help to produce power, and at the same time it will also reduce that noise level. So this is more like the expectation that's annual generation that's coming from wind. So by 2030 we are expecting that almost like world 20% like annual install capacity, annual install generation, that would be from wind. But again, I mean, actual generation would be definitely less than the actual capacity. But we expect that a significant part actually come from wind. So like solar, wind also like different sort of like new blade that's coming in the market, which is less noisy, and even some wind turbine that is going bladeless, even that's like produce power from oscillation. And there are many new innovative manufacturer and materials that is also coming in the market to improve the energy efficiency from the wind turbine. That will be discussed in details when we will be talking about wind turbine. And like solar, wind generation both onshore and offshore, that is increasing in terms of total capacity as well. Even if you think about the individual rated energy that you can get it from individual wind turbine, that is also gradually increasing. So initially, it was like 50 to 100 kilowatt, but as I mentioned, currently even you can get like 7 to 9 megawatt from a single wind turbine. And who knows, and in coming years, even it might be like 15 to 20 megawatt from a single wind turbine. And same as like in power electronics, as I mentioned that probably in future we will use like more silicon carbide and gallium nitride. We'll use more intelligent and less iron and copper, because that will actually help us to improve the overall energy conversion efficiency. Because when you're talking about like a photovoltaic efficiency, that's only that energy conversion from solar to electrical. But when you're talking about the overall photovoltaic system, that also include the inverter and converter. So that's why we also need better efficiency from power electronic devices, and that will come from as I say, like, better switch like silicon carbide, gallium nitride, and more intelligent control and optimization that will be using, inside the material. What about like inductor transformer? There will be some inductor and capacity in the system, because we can't get rid of 100%. But as I say, like it would be less and less, and at the same time, that there are also different researches going on to use high frequency transformer, which also have got very high efficiency. And at the same time, you might also heard about like solid state transformer, which is like the not only the normal transformer, which is just like step up or step down the voltage and current. So it would be like power electronics inverter converter plus the normal transformer. So that will do that voltage and current step down or step up, but at the same time it will also include many control capability with the transformer as well. So as I mentioned, like that central control intelligent that will coming from definitely software control. That would be a important part of that future technology. We'll be using like magnetic capacitor, but that would be less. So active like power transistor component, that would be the mostly major components in the future technology. And then in terms of control, the digital control that will dominate over analog control, because it has got many advantages that probably you already know. So that's some of them already are in the market, and some of them even coming in coming 5 to 10 years. So what I'm trying to say that this digital control would be the popular for power electronics inverter and converter in coming years. And as I mentioned also previously, there's even like multi-input, multi-output converters, because we are using converter, inverter in our home for different application. So instead of using like several individual inverter converter, why don't use just like multi-converter, which have got different multiple input and multiple output, and use this one for hybrid application that will help us to improve the overall efficiency as well. So that's all probably I would like to say. And other one I already mentioned, that multi-objective optimization, that is also getting popular when you like to design any system, even like finding the appropriate components level, and even if you go for that system level, we are using multi-objective optimization just to make sure that our design, our operation, our planning, everything is optimal, just to make sure that the overall system is more energy efficient, more cost effective, and that would make everything affordable for the consumer as well. So just to conclude, although we'd like to improve energy efficiency, but we need to agree that we cannot make those device loss free. There would be some losses. There will be some energy loss, and that's why we need to use some heat sink. But as I mentioned previously, would like to reduce as much as possible. But sometime, if you would like to make it more energy efficient, it will also, increase the cost as well. So sometime it happens that you would like to increase the efficiency by 1%, but to do that, the money that you'll be spending is not like at the end, it's not like feasible to do that, because the power that will be saved and the money that you will be spending to save that power actually does not make sense. So that's why sometimes also we need to think about that trade-off between increasing the efficiency and the money that we'll be spending to improve that cost. So that's why sometime, I mean, we have to think about that was the maximum efficiency that we would like to achieve, which is feasible. And you already know that energy actually circulate in the inverse, right? I already mentioned in the very beginning that it does not destroy it or does not, produce. So we need to recover the energy from the heat, because as I mentioned that most of the energy is lost in terms of the heat. So if you need to find a way to utilize those heat from all the devices, from all the system that's happening in different sector, then actually we can save like, millions or billions of dollars annually. So that's why, I mean, there are several researches going on that how actually we can utilize those energy that is lost actually in terms of heat. So that's why I mentioned here that we need to find out a way. Probably we need more research to find, again, I mean, more advanced way to convert energy. So that might be helping us to reduce the losses, and at the same time, even if there is a losses, I mean, how we can use that losses which is happening in terms of the in terms of the heat. So just to conclude, I mean, the fact that, as I say, like, power conversion, it is our way of life. It is happening now. It will happen in coming years. So we need to find out to reduce the loss, and to do that, I mean, we need to have more, semiconductor, less iron and less copper. We need more control intelligent. Again, I mean, less from iron and copper. There will be silicon because it is utilizing now, and also it will be utilizing in coming years as well. But as I say, like, wide band gap technology, that would be more popular in coming years. So even now, there's a research that whether we can find even better switches compared to silicon carbide or gallium nitride. And I know that there are some researches already going on, and I'll share some of them in coming in coming lectures. In terms of like magnetic and capacitor, if you think about that improvement, I think that is not progressing that well, because people are not focusing that much on magnetic and capacitor, honestly. So probably we need to do something more on that to improve that their performance. Again, there will be many more new technology, but again, some of the old technology that probably will continue to use in the coming years as well. In the coming years, we'll be having more like a hybrid with software and hardware platform. And as I say, like multi-objective optimization and better control that will come into the picture, not only the energy sector, but I think in other sector as well. So with that, all I would like to share today. So still, we have got 10 minutes. So if you have got any comments or question, please feel free to share with me. Thanks for your attention.
Yeah, we can open for questions. there are any questions from the participants, you are most welcome.
Any comments or question? Or even, I don't know, I mean, does it make sense? I mean, what I already shared with you.
Yeah, this course is more to be an interactive one.
But again, I mean, today, as I said, this is more like the only introduction and background of like the energy conversion technology. But as I said that, I mean, in terms of the individual technology, I mean, we'll start from tomorrow. Probably tomorrow I'll be talking about solar photovoltaic system.
Sir, Sandeep, you have any question?
Yes, thanks, Professor. Yeah. So today we got overall a broad picture of everything. It is just like a motivation for to start this course. Thank you very
That's
much.
right. Thank you.
Different aspect of energy. Energy is not like electrical. We are thinking, but solar energy, wind energy, heat, and electricity. Many form you discuss. This is just we are just ready now for tomorrow.
Yeah, that's I mean
Very
my
nice
expectation as
motivation.
well, that if you just get, I mean, something that you are thinking that this is like the big picture in energy conversion, like overall picture. I believe, like, not everybody is working in everything that we discuss. Some people might, be in the photovoltaic system, someone might be wind, someone might be the battery, someone in the system level. But this is something you just think about, like, in the course, like where probably you fit yourself. But as I mentioned, like, although you are working in a particular sector now, but you never know that, in coming years, you might be working in other sector. So it's not a bad idea actually to have some understanding about what is happening outside, I mean, our own area of interest as well.
Yes.
Resma, you wanted to say something?
Hello?
Yes.
Yes, Resma.
Yes, sir, this is Resmo. Sir, you showed me some digital controllers, and we are using for hyper applications to control the over voltage. So we can use the embedded technique in the controller side, sir.
So you are yeah, I mean, I just missed. So your control is to control the high voltage, or what you mentioned? I just
Sir,
can you
controlling
repeat
the
it
high
again?
voltage power, sir. Controlling the flow of over current and over voltage. To
So you're
maintain
controlling
the
over current and over
constant.
voltage.
Yes, sir. Yes, sir.
So I mean, you are trying to achieve constant voltage and constant power, something like that, or?
Yes, sir. To maintain constant current and constant voltage, so that we can use the embedded technique in the controllers.
Yeah. So, I mean, what sort of technology currently you are using? I mean, what sort of controller currently you are using?
Sir, I have decided to take a kind of microcontrollers, but it is used for the low power applications only. So apart from that, can we use some Raspberry Pi or Python kind of techniques, controlling techniques?
Yeah, definitely. I think you can, and as you might, I mean, know that, like controlling from the, like, if you think about like control from the software side, the Python is getting popular all around the world. So even like in Australia, I know that, I mean, if someone knows Python, I mean, it's not difficult to get a job because it is an open source, and most of the industry currently now they are intending to use Python. And just to answer your question, I think it's possible to do from Python. And I'm not sure. I mean, I'll be getting enough time to go for details about the control, but
Okay, sir.
I'll try to show some, I mean, control application in the power system side. So that might not be a, like, microprocessor based control, but it would be like other sort of mainly robust control technology that we utilize in the energy sector. But I definitely believe
Yeah,
that you
yeah,
can
okay,
use
sir,
that
sure,
one.
sir. And here mainly this Tesla in electric vehicles, they are using many programming techniques in the controlling side. So if it is possible, so you can share me in your presentation what kind of controllers they are using for the loading the program.
Yeah, I'll show some. I mean, I'll be talking about electric vehicle. Thank you. So I mean, again, yeah, that's a good one. I mean, if you would like to see something, feel free to share with me, and I'll try to highlight that when I'll be presenting that particular, I mean, energy conversion technology. Thanks, Reshma. I mean, I appreciate that. So if
Sir,
anyone,
can you please show me the fifth slide? You shared some books. You suggested some books. So can you display me that once again, sir, so that I can notice?
so you want to see that slide again?
Yes, sir. Fifth slide, sir.
Here, I mean, I didn't explain, I mean, how you can implement control, or here I just mentioned that these are the future that is coming in the energy sector. So which slide you are interested?
Sir, please first show me the fourth slide, sir. Yeah, controllers.
There's some slide in which the books were mentioned.
54th slide, sir.
54.
No, it's the fourth one. Fourth
Yes,
one.
sir.
Yeah.
This one.
This is this the one?
Yes, sir. Next slide, sir. 55.
So here I talk about, like, FPGA, DSC. I mean, this sort of, like, a hardware control platform. And I just highlight that it has got like many PWM channel. You have got many analog to digital, converter port. Your control frequency is like also very high, up to megahertz, and you need a very simple communication. That's why this sort of platform might be popular, in coming years.
Okay, sir. Okay. Sir, finally, please display me the fifth slide, sir. You suggested some books to read. Can I note that, sir?
But again, I mean, I will also share this slide. You will get that slide as well. But the book that is mostly a renewable energy side, not the control side.
Okay, sir.
I mean, this slide?
Yes, sir. Thank you, sir. Thank you so much.
No problem. Thank you.
That's all, sir. Thank you.
Any other questions?
Anyone else, like any comments or anything you would like to show in coming weeks, or sorry, in coming days?
One more thing, Dr. Jahangir, I would like to point out here, but from mechanical engineering also.
I think your voice is not that clear.
Now is it okay? Now is it okay?
We can hear, but it's not that clear.
Just no.
Yes.
Now is it
No, we can't hear you clearly. What about other audience?
No, sir. We are not able to hear you properly.
Yeah.
No, sir.
I don't know. There is some issue probably. I don't know with your sound system.
Dr. Altaf, we are not able to hear your voice, please.
till the last one? It was okay. Just one second. Okay.
Yes, Altaf. I don't know. Initially, it was sound was okay.
Yes. Sir, try to shout.
Speak.
Sir, you disconnect that headphone and talk with laptop microphone, sir. You try it.
Actually, I disconnected it, but it's still not working.
Oh, no, we can't hear you.
Now is it okay?
No, sir. It's
No,
still a lot of disturbance. Yeah, we cannot. You can write now.
What
In the chat.
happened?
If you can type the comments, sir, in the comment section.
Something has gone.
No, Altaf. Something wrong. Maybe we can hear it from you maybe tomorrow.
Yeah. Oh, what? I type in the chat box.
So anyone here, in the participant who is doing his PhD in like any of this technology that I mentioned, or even like a master's student who is working on the area that I mentioned? Okay, Aldab, I mean, you mentioned like there are people from mechanical department as well. Yeah. Thank you. I forgot to ask that question, that whether I was going too fast. Yes, thanks for that. And from tomorrow, I'll try to go slowly. Because what happened, like sometime, online, when you are presenting, actually you are not seeing anyone, and sometime, you just speak. So that's why, I mean, I always prefer that at least some of you keep your video on, so that I just feel comfort that I'm speaking in front of some people.
Yeah, that's correct. You also ask, is everything is going fine? Is my voice is clear?
Yeah. And when I'm actually also teaching in Australia, I always, ask my student just to keep your video on. Although, not everyone like to keep video on, but if you keep your video on, it seems like more like lively environment, and seems like you are talking in front of some other people. But everything, screen is off. You feel like, you're just speaking yourself, and feel like, completely disconnected sometime. Yeah. Anyway, probably if you don't have any question or comment, I'll leave it here, because here from my side it's like night 10:34. p.m. So that's why I requested Altaf from tomorrow start a little bit earlier so that I can finish during my evening time. Okay, so that's all. Thanks for your attention, and I hope to see you tomorrow. Thanks, everyone.
Thank you, sir.
Thanks, sir.
Thank you. Bye.
Thank you, sir.
Sir.
Participants, am I audible a little bit?
No, sir. Still disturbance.
Sir, still not problem.
Anyways, I'll just try and shout. Yeah, attendance is compulsory.
You got some. I mean, when you're talking, there is some echo coming. I'm not sure. Can you try to mute everyone and talk by yourself and see how it goes? Mute everyone.
Now is it okay?
No.
Okay. Let it be. There is some construction work going on actually.
Anyway, we'll see. I mean, how it goes tomorrow. Okay. Thank you.
No, for participants, I would say that attendance is compulsory. So please, you need to attend the sessions. If you are unable to attend, please let me know. Right? Rather than having issues later on, we need to have it. And maybe tomorrow we can have some interactive session also. Today it was a little bit tight because it was night in Australia. So maybe we'll have some interactions. So we'll close for the day. Thank you all. Thank you very much.